honestly, they completely dismantle the standard approach to physical training.
Yeah, they really flip the whole script on how we look at working out.
Right. We're pulling from some deep discussions featuring exercise physiologist Dr. Andy Galpin, the foundational principles of strength coach Pavel Tsatsouline, and some really practical insights on training styles for my group.
And the overarching mission for today, for you listening, is to decode the physiological adaptations of the human body. We want to stop treating a workout like, a mechanical chore.
Checking off a box.
Exactly. Where you just move a weight from point A to point B. Because by the end of this conversation, you'll understand how manipulating specific variables and even manipulating your own conscious thoughts puts you right in the director's chair of your own biology.
It's wild. And to give you an idea of how dramatic this shift in thinking is, consider this. What if simply looking at your bicep while curling a dumbbell actually changed your nerve recruitment and grew more muscle?
Right, without changing anything else.
Yeah. Not lifting a heavier weight, not doing more reps, just directing your visual and mental attention to the muscle tissue itself.
Which sounds crazy, but in the world of exercise physiology, that phenomenon is thoroughly documented. It's fascinating. The mechanical movement of a joint does not dictate the adaptation your body makes. The specific execution and crucially the neurological intent behind the movement, those are what signal the tissue to change.
Okay, so if intent is the trigger, we need to figure out what foundational physical quality we're even aiming for, right? Because according to Pavel Tsatsouline's philosophy in our sources, before we talk about endurance or even muscle size, there's a physical baseline that everything else just has to sit on top of.
Yeah, he calls it the mother quality.
The mother quality.
Right, strength. Without a base level of absolute strength, your ability to build speed, endurance, or muscle mass is it's severely capped.
I think the definition of strength gets really blurry for a lot of people, though.
Right.
Someone might do a tough boot camp class, lift some kettlebells for 45 minutes, feel completely exhausted, and think, hey, I just did a strength workout.
Oh, absolutely. That happens all the time. But Dr. Galpin and the My Protein source draw a very hard line here. Feeling exhausted is not the same thing as signaling your nervous system to build strength.
Right.
True strength development requires a very specific environment. Heavy loads. You're looking at operating at or above 85% of your 1 rep maximum, usually for 5 or fewer reps.
Let's pause there for a second, because 85% of the absolute maximum weight you can lift for a single rep, that is incredibly heavy.
It is. It's extremely demanding.
And most people just do not train in that zone.
Yeah.
So what is happening at a cellular or, a neural level at 85% that doesn't happen at, say, 60%?
Well, the difference really lies in motor unit recruitment. A motor unit is basically a single nerve fiber and all the muscle fibers it connects to. Your brain basically operates on this principle of energy conservation.
Because it's lazy.
Exactly. It wants to be efficient. So if you lift a light weight, your brain only sends a weak electrical signal. It recruits these small, slow-twitch motor units. They don't use much energy, and they can go all day.
Right, like carrying groceries.
Right. But when you load a bar to 85% of your maximum, the brain panics. It realizes we need more power right now. So it has to send a massive, high-voltage electrical signal to recruit your high-threshold motor units.
Ooh, wow.
And those are your fast-twitch muscle fibers.
Because the weight is so heavy, you can only manage maybe 3 to 5 reps before the muscle just completely stops working.
Yeah, the nervous system simply cannot sustain that high-voltage output for very long. This is why the primary driver for strength is intensity, meaning the actual weight on the bar, not the volume of reps.
This also explains the rest periods, right? Because I've always found it so frustrating to sit on a bench for 3 or 4 minutes between heavy sets.
Oh, it feels like an eternity.
It feels like I'm wasting time. But if I only rest 60 seconds, I invariably fail on the next set.
Yeah, and that's because your muscle tissue might feel fine after 60 seconds, but the energy system powering that high-voltage electrical signal, the ATP creatine phosphate system, it needs a minimum of 2 to 4 minutes.
2 to 4 minutes.
Sometimes up to 5, just to fully chemically recharge. If you rush the rest, the nervous system can't fire at maximum capacity.
So you end up having to drop the weight.
Exactly. And the moment the load drops below that 85% threshold, you are no longer sending the build strength signal to the body. You are just practicing being tired.
Wow. Okay, so Dr. Galpin highlighted a detail about those specific fast twitch fibers that, honestly, it changed my entire perspective on aging. Because we tend to think of heavy lifting as, a young person's game.
Right, people think you should back off as you get older.
Yeah, but the research points in the exact opposite direction.
It really does. As humans age, we don't just lose muscle mass uniformly. We preferentially lose those high-threshold fast-twitch fibers.
It's just the fast-twitch ones.
Primarily, yes. The body essentially prunes them away because they are metabolically expensive to keep around.
It makes sense. It's kind of like having an expensive sports car in the garage. If you never take it out and drive it fast, the battery eventually dies, the seals dry out, the engine seizes up.
That is a great analogy.
The car degrades precisely because it's never pushed to its limit, right?
Yeah, because the human body is remarkably efficient. If you only ever do low-force movements, walking, jogging, lifting light objects around the house, your nervous system assumes you have permanently retired the need for maximum force production.
It's like, well, we don't need these anymore.
Exactly. So it lets those fast-twitch fibers die off. And that loss is a primary driver of the frailty, the mobility issues, and metabolic decline we associate with aging.
That's terrifying.
It is. The only known biological mechanism to halt that decay is to demand the muscle to produce high force.
Okay, so that raises a really practical question. If I just need to demand high force to keep the engine running, can I just get under a heavy barbell, unrack it, and survive the lift? I mean, if the weight is heavy enough, my fast-twitch fibers have to engage, right? Does my mental state during the lift even matter if the physics are demanding it?
The physics will force a certain amount of recruitment, sure, but mere survival leaves a massive amount of adaptation on the table. This brings us right back to your opening example about looking at your bicep.
The mind-muscle connect.
Exactly. The mechanics of the lift are just the prerequisite. The psychology of adaptation, your conscious intent, is the actual catalyst.
I have to admit, when I first read about this in the sources, my instinct was to dismiss it as, like, Jim Bro pseudoscience.
Yeah.
The idea that just thinking about a muscle makes it bigger. It sounds like magic.
It really does sound anecdotal, but researchers are finding it's grounded entirely in neural pathways. The mind-muscle connection is the practice of being intentionally present and focused on the specific target muscle during the movement.
Right.
Rather than just checking off the box to complete a set, you're focusing on the internal representation of the movement. Let's look at how this changes based on your goal, though. If your goal is hypertrophy, building muscle size, the research reveals something really startling.
Right, the bicep curl study.
Yeah. In a controlled setting, if a person performs a bicep curl with a specific weight for 10 repetitions, but they actively watch the muscle and consciously squeeze it as hard as possible throughout the whole range of motion, the muscle physically grows more.
Than if they just did it normally.
Exactly. More than if they did the exact same weight and reps while just, staring at the wall or thinking about their grocery list.
Even though the mechanical tension is identical, the tissue growth is different. I mean, how does a thought turn into tissue?
Because the conscious focus amplifies the electrical signal at the neuromuscular junction. By actively thinking about contracting it harder, your brain forces a denser, more synchronized firing of motor units. You are recruiting more internal fibers to do the same external work.
Oh, I see.
So your body registers a greater physiological threat, and it overcompensates by building more tissue. You're striving for a physiological adaptation, not just a mechanical task.
That makes total sense for hypertrophy, where you want to exhaust the muscle to make it grow. But if we pivot back to strength and power, I'm not trying to feel a deep muscle burn. I'm just trying to move a very heavy object. Does the mind-muscle connection still apply there?
The target of your focus shifts, but the principle totally remains. For strength and power, the intent must be to move the weight as fast as humanly possible.
But wait, if I have 90% of my max on a barbell, it's going to move slowly. Like, the physics literally won't allow me to move it fast. So my intent just defaults to pushing hard enough to not get crushed by the bar.
Right. The bar speed will be slow. But your neurological intent to accelerate is what actually matters. Scientists measure something called rate of force development. It's how quickly your brain can go from 0 to 100% electrical output.
Okay.
If you just push hard enough to successfully complete the rep, you train your nervous system to be a tractor. Strong, but slow. If you actively intend to violently accelerate that heavy bar, you train your nervous system to be a dragster.
Oh.
Yeah. Even if the bar moves at the exact same physical speed in both scenarios, the intent to accelerate forces the brain to fire those fast-twitch motor units simultaneously rather than sequentially. That generates vastly superior strength and speed development.
It is so fascinating that the brain is quite literally the control panel for the physical outcome.
Yeah.
But there is a massive point of friction here for a lot of people.
What's that?
What if the control panel is, like, disconnected? We've all done an exercise like a back row where you're trying to use this mind-muscle connection, but you only feel your arms working. The target muscle is just completely numb or stubborn.
Yeah. Oh, yeah. Dr. Galpin addresses this as a highly common neurological roadblock. The brain has basically lost the map to that specific muscle, usually due to poor posture or just disuse.
So how do you fix it?
This is where coaches step in with tactical prompts. It's a key tool for awareness and activating difficult-to-target muscle groups, forcing the brain to find that pathway.
So instead of just telling someone, use your back, what does a tactical prompt actually look like?
Well, a coach will often physically tap the trainee's lat muscle during the exercise and give a tactile cue, like squeeze my finger.
Oh, okay.
The brain processes that external sensory input, suddenly locates the muscle, and fires the correct pathway.
The sources mentioned another trick for this that I thought was brilliant. Eccentric overload.
Ah, yes, using the negative phase of the movement, because a strong mind-muscle connection ensures the technique is correct, like maintaining control during the eccentric phase.
Right. The example given was a pull-up. If you can't feel your back muscles engaging, you don't just hang from the bar and flail around. You step on a box so you're already in the top position with your chin over the bar.
Yep.
Then you step off and fight gravity, lowering yourself down as slowly as possible. Why does that downward phase wake up a stubborn muscle?
Because during the eccentric or lowering phase, the muscle fibers are actively lengthening while under tension. At a microscopic level, the little cellular hooks that contract the muscle, actin and myosin, they're being physically ripped apart, much like Velcro.
That sounds painful.
Well, because the muscle is lengthening under load, the nervous system has to apply a massive braking force to stop you from just dropping to the floor. That extreme braking demand forces the brain to hyper-focus on the target tissue. It builds the neurological map very quickly.
It's like forcing the brain to acknowledge the muscle even exists.
Exactly.
So we've established that heavy loads build the strength baseline, and intense mental focus amplifies the quality of the adaptation. But this naturally leads to kind of a threshold question.
Okay.
If I'm doing 10 reps, I'm building size. If I drop the weight and just keep doing rep after rep, say I hit 25, 30, or 40 reps, do my fast twitch fibers just explode with massive growth from all that volume?
They don't, because of the physiological limits we discussed earlier. Your fast twitch fibers fatigue very quickly.
Yeah.
Once you cross into that high rep range, those high threshold units drop out entirely, and your slow twitch endurance fibers take over the workload.
The sources describe this as crossing the something else threshold.
Right. Hobble-Satzline and Dr. Galpin note that once you can perform more than 15 to 20 repetitions of an exercise, body weight dips are a great example, the stimulus fundamentally shifts.
You're doing something else?
Exactly. You are no longer primarily building strength or optimal muscle size. You are crossing over into aerobic work and muscular endurance. According to the sources, muscular endurance is basically defined as your ability to perform a high volume of work over a specific time frame, like how many push-ups you can do in 1 minute.
So the moment you start doing sets of 40 reps, your body realizes it's playing a completely different sport.
A totally different sport.
But endurance isn't just one thing, right?
Yeah.
Because my arms burning out on push-ups feels very different than my lungs burning out on a long run.
That's a great point. Dr. Galpin categorizes endurance into a spectrum of specific time domains, and each is driven by a different biological mechanism. The first one is muscular endurance.
Okay.
This is short-term, highly localized muscle fatigue. Think of that 1-minute push-up test. Your chest and triceps are screaming, but you aren't necessarily gasping for air.
Right. That burning sensation in the local muscle, that's the buildup of hydrogen ions and lactic acid because oxygen can't get to the tissue fast enough, right?
Exactly. The muscle is producing waste products faster than the local blood flow can clear them. The system gets acidic, and the muscle physically shuts down to protect itself. But if you move to an exercise that involves the whole body, you enter the anaerobic power domain.
And what's the time frame for that?
This is 30 seconds to 2 minutes of all-out effort, like a vicious sprint. Now, the fatigue is systemic. The entire body is flooded with waste products.
And if you try to push that systemic fatigue past the 2-minute mark, you eventually hit a wall where your breathing takes over.
Right. That is the VO2 max domain, which spans roughly 3 to 12 minutes. VO2 max is the maximum volume of oxygen your body can physically intake, transport through the blood, and utilize inside the mitochondria of your cells to create energy.
Wow.
In this domain, the limiting factor isn't local muscle acid anymore. It's your cardiovascular engine's sheer capacity to process oxygen.
And if you dial the pace back just enough to survive past 12 minutes, you settle into that final domain.
Long duration endurance, 30 minutes or more without a break. Here, you found an equilibrium. Your body is clearing the cellular waste at the exact same rate it's producing it. The absolute speed matters less than the simple mechanical and energetic ability to sustain output without breaking down.
Okay, so if I want to train my body to reach that equilibrium, to clear waste efficiently and sustain work, how do I manipulate my workout to signal that specific adaptation? Because clearly, the heavy 85% one-rep max strategy we use for strength is going to fail miserably here.
That won't work at all. You have to adjust what exercise science calls your modifiable variables.
Sure.
Intensity, volume, rest intervals, and your choice of exercise. To build endurance, you basically turn the dials in the opposite direction.
Okay.
First, intensity drops significantly. You intentionally choose lighter weights or body weight movements.
Why does the weight have to drop, though? Couldn't I just try to do 40 reps of a heavy weight?
Because a heavy weight forces the recruitment of fast twitch fibers, which fatigue in seconds. By using a lighter weight, you bypass the fast twitch fibers and rely on the slow twitch fibers. This sends a chemical signal to the cells to build more mitochondria.
The cellular power plants.
Right, rather than thicker muscle tissue. You are signaling a need for energetic efficiency and tissue tolerance, not absolute power or size.
That makes sense. So that shifts the focus to volume then. The total number of reps becomes the primary driver. We're striving for high repetition counts to constantly challenge those cellular power plants. But what about the rest intervals? For strength, we needed a long coffee break of 4 minutes to let the nervous system recharge.
Endurance training utilizes significantly shorter rest periods. You intentionally prevent the system from fully recovering between sets. By keeping the rest short, you force the local muscle and the cardiovascular system to adapt to energetic fatigue.
It's like that strength training scenario is a demolition crew swinging a heavy sledgehammer. They need a long break so their nervous system has the power to shatter a concrete wall with one swing.
Exactly.
But endurance training isn't about maximum power. It's about taking away the crew's brakes entirely, forcing them to learn how to efficiently sweep up the rubble and process the waste all day long without stopping.
I love that. The adaptation happens precisely because the system is forced to function while fatigued. And to keep improving that efficiency over time, you have to apply progressive overload tailored specifically for endurance.
Right, so you don't add more weight to the bar.
No, you add more repetitions to your sets over time. Or you decrease the rest intervals between sets, maybe shave 10 seconds off. Or you increase the frequency, meaning how many days per week you perform that specific endurance-based movement.
I mean, when you step back and look at the entire physiological picture we've painted today, the amount of control we have is just staggering.
It really is.
Whether you are lifting heavy to save your fast twitch fibers from aging or depriving your muscles of rest to build mitochondrial efficiency, you aren't at the mercy of your genetics.
You are the director.
You, listening to this, you are actively holding the script.
Yeah.
By combining the precise mechanical variables, the weight, the reps, the rest, with a fierce, calculated mind-muscle connection, you dictate the exact terms of your body's adaptation.
And honestly, the depth of that mind-muscle connection leaves us with a rather profound implication to consider.
What's that?
Well, we've established that the nervous system's link to the muscle is exquisitely sensitive to conscious thought. Directing your visual and mental attention to a bicep alters nerve recruitment enough to literally change the physical size of the tissue.
The control panel is incredibly responsive.
It is. So, if the neural system is that delicate, how much does daily cognitive fatigue sabotage our physical fitness?
Oh, wow.
Consider the modern workday. Sitting at a desk, processing endless streams of data, managing stress, answering emails all day. That deep cognitive drain consumes massive amounts of neural energy. By the time you step into the gym, are you already physically compromised?
Because your nervous system is fried.
Exactly. If your brain's electrical capacity is exhausted from stress, you simply may not be able to generate the high voltage signal required to recruit those vital fast twitch muscle fibers, no matter how heavy the barbell is. Your cognitive state might be the very ceiling of your physical strengths before you even start the workout.
That is a brilliant and frankly kind of unsettling realization. Mental exhaustion isn't just a feeling, It is an actual physical barrier to adaptation. We'll leave you to process that the next time you try to lift heavy after a draining day at the desk. Take these variables, take control of your intent, and change your training. We'll see you next time on The Deep Dive.